Okay, I hope I'm audible to all my students who are attending this particular lecture for the Statistics for Business Economics Part 1 course. In this particular lecture, I'm going to continue with the discussion of the 2024 question paper, which has come up at Delhi University for the Statistics for Business Economics Part 1 course. And this lecture is recommended for all those students who are pursuing BA Honors Business Economics from University of Delhi, currently in their semester 2. Okay, now all students can recall that in the previous lecture, we had solved all problems from question number 1. Okay, now in this particular lecture, I'm going to start with the discussion of problems from question number 2. So first of all, I hope all students can see question number 2 on your screens. Let's quickly start from the discussion of this particular problem in this particular lecture. So let's start with the discussion of this lecture. So within question 2, let's read part A. If the probability that student A will fail a certain statistics examination is 0.5 and probability that student B fails the examination is 0.2 and the probability that both students A and B will fail the examination is 0.1, what is the probability that at least one of these two students will fail the examination? It's a typical question based on probability. Okay, so let's quickly come to the whiteboard and let's quickly solve this particular problem on the whiteboard. I'm just writing the main heading for completeness. We are looking at Delhi University exam 2024. Just revising that the name of the course is Statistics for Business Economics. Statistics for Business Economics Part 1 course. And this is recommended for all those students who are pursuing BBE honors from University of Delhi. Okay, we are looking at question number 2. Within question number 2, we are solving part A, part 1. So I can say that let the event A denote the probability of student A failing the exam. Probability of student A failing the exam and let the event B denote, let event B be equal to the probability of student B failing the exam. Probability of student B failing the exam. Now, in the question, we are given that probability that student A fails the exam is 0.5. Probability that student B fails the exam is 0.2. And if I come back to the question paper, probability that, okay, we are on this. Probability that student A fails the exam is 0.5. Probability that student B fails the exam is 0.2. Probability that both students A and B fail is 0.1. So that means probability of A intersection B. Probability of A intersection B is 0.1. This is the probability of both the students failing the exam. Now, what is the question asking us? What is the probability that at least one of these two students will fail the exam? Remember from my lectures on elementary probability theory, whenever they ask at least one, they are asking you union. So I can say that probability that at least one of them fails the exam, probability that at least one fails the exam is simply the probability of A union B. And probability of A union B is probability of A plus probability of B minus probability of A intersection. So probability of A is how much? 0.5. probability of B 0.2, probability of A intersection B 0.1. So this comes out as 0.7 minus 0.1, which is 0.6. My answer is 0.6. This is the probability that at least one of them fails the exam. Okay, so this is my answer for part 1. Probability of A union B is 0.6. Coming back to the question paper, let us see what's the next part asking us. So part 2, we are done with part 1, now part 2. P of A is 0.3, P of B is 0.2, P of A intersection B is 0.1. We need to determine P of A union B, P of A not A intersection B, P of A intersection not B, P of A union not B. Remember, A complement means not A, B complement means not B. So we have to use the laws of set theory to answer this question. And I've covered all of this in quite depth in my lectures in elementary probability theory. So question 2, part A, within this part 2, I'm writing what is given to us. We are given that probability of A is 0.3, probability of B is 0.2, and probability of A intersection B is 0.1. Okay, so now we are going to solve for what question is asking us. So the first part asks us to find out probability of A union. We directly apply the formula. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. Now probability of A is 0.3, probability of B is 0.2, probability of A intersection B is 0.1. So 0.3 plus 0.2 is 0.5, 0.5 minus 0.1 is 0.4. This is the probability of A union B. It's 0.4. Okay. Then the second part was asking us what within this? We need to find out the probability of not A intersection B. That means, in other words, the question asks us to find out the probability of only B. Now, only B is nothing but from probability of B, I subtract probability of A intersection. This I can also write as probability of only B. Only B means B but not A. So it's probability of B. From probability of B, I subtract probability of A intersection B. Probability of B is 0.2. Probability of A intersection B is 0.1. 0.2 minus 0.1 is 0.2. Then the question asks us to find probability of A intersection B complement. In the bracket, I can also write this as probability of only A. Now, how do I find this? From probability of A, I am going to subtract probability of A intersection. That will give me probability of only A. That means A but not B. Probability of A is 0.3. Probability of A intersection B is 0.1. 0.3 minus 0.1. Okay. And then we are going to find out probability of A union B complement. So if I erase some portions off, let me erase this initial portion off. So part 4, we find probability of A union B complement. We apply the formula here directly. Probability of A union B complement is probability of A plus probability of B complement minus probability of A intersection B complement. Now, probability of A is 0.3. Probability of B complement is just 1 minus probability of B. I'm writing it here, guys. Probability of B complement is just 1 minus probability of B. How much is probability of B? 0.2. So 1 minus 0.2 is how much? 0.8. Minus probability of A intersection B complement, I have already calculated. See, from part 3, probability of A intersection B complement is how much? 0.2. So this is going to be 0.3 plus 0.8 is 1.1 minus 0.2, which comes out as 0.9. This is my answer for probability of A union B complete. Okay, so hoping all students have understood this. So if I come back to the question paper, okay, let's look at the next part now. A joint probability mass function for discrete random variable x and y is given as follows. Okay, so students can see the joint probability distribution function. I have covered these kind of questions in my main lectures on joint probability distributions. We are given the values of x, we are given the values of y, and we are given the corresponding probabilities. The first part asks us to calculate expected value of x. Second part asks us to calculate the variance of y. Third part asks us to find the conditional distribution of x when y is greater than or equal to 20. So let me first of all come to the whiteboard and let me write this table on the whiteboard. So we are on to question 2 part B. I am first of all writing the table which shows the conditional the joint distribution between x and y. So the values taken by x are 5, 6, 7. Values taken by y are 10, 20, 30. Probabilities are as follows. 0.1, when x takes the value 5, y takes the value 10. 0.05, when x takes the value 5, y takes the value 20, 0. Then we have 0.15, 0.25, and 0.05. And then we have again 0.05, 0.2, 0.15. Okay, so this is my joint probability distribution table given to us in the question. Now, first thing, the question asks us to find expected value of x. Now, for that, I need the values taken by x and I need the marginal PDF. That means values taken by x are 5, 6, and 7. And I find the P of x. How do I find P of x? What's the probability of x taking the value 5? 0.1 plus 0.05 plus 0, which comes out as 0.15. What is the probability of x taking the value 6? 0.15 plus 0.25 plus 0.05. How much this comes out as? 0.45. This comes out as 0.45. What's the probability of x taking the value 7? 0.05 plus 0.2 plus 0.15. So this comes out as 0.4. Now, what is the expected value of x? Apply the formula. We have done this in the main lectures in discrete random variables as well as joint probability distributions. Access for all these topics is given to students who have subscribed to my complete course for Statistics for Business Economics Part 1. So expected value of x is summation xpx. This is 5 into 0.15 plus 6 into 0.45 plus 7 into 0.4. Now students can use your calculators and you can verify that the expected value of x comes out as 6.25. Use your calculators and verify that expected value of x is 6.25. So this is my answer for expected value of x. So first, from the joint distribution table, we have to first find the marginal. We have to first find the marginal PDF of x, which is values taken by x with corresponding probabilities. Probability of x taking the value 5 is 0.1 when y takes the value 10 plus 0.05 when y takes the value 20 plus 0 when y takes the value 30. So you add them up. 0.1 plus 0.05 plus 0 gives you 0.50. Similarly, when x takes the value 6, what's the probability? 0.15 plus 0.25 plus 0.05, which is 0.45. And probability of x taking the value 7 is 0.05 plus 0.2 plus 0.15, which is 0.5. This is how we work out the expected value. Now, the question was also asking us to find the variance of y. So first I find the So part 2 within this, first I find the marginal PDF of y in order to find the variance. So part 2, variance of y will be, we have to use the formula for variance. I've covered this in my lectures in statistics for business economics. It's expected value of y square minus expected value of y whole square. Now first I need to find the marginal PDF of y. From the joint we calculate marginal PDF of y. So the values taken by y are 10, 20 and 30. And the corresponding probabilities now will be in blue color, 0.1 plus 0.15 plus 0.05. How much that comes out as? It comes out as 0.3. Then 0.05 plus 0.25 plus 0.2. How much it comes out as? It comes out as 0.5. And then 0 plus 0.05 plus 0.15 comes out as 0.2. Okay, so then we how do we calculate expected value of y square? It is summation y square into p of y minus expected value of y itself is summation y py whole square. So first I calculate y into py, that is just multiplying these two columns. So 10 into 0.3 is just 3. 20 into 0.5 is how much? So 20 into 0.5 is just 30. Let me correct myself. 20 into 0.5 is 10. And 30 into 0.2 is 6. So if I add them up, it is 19. And y square into py will be how much? Just multiply ypy column with y again. So 10 into 3, 30. 3 into 10, 30. 10 into 20 is 200. 6 into 30 is 180. So if you add all of them up, you get 410. That means my variance of y will be 410 minus 19 square. Summation ypy was 19. So 19 square. So this comes out as 410 minus, how much is 19 square? 361. How much is 410 minus 361? 49. That means my answer for variance of y is 49. So hoping students have understood this. Variance of y is 49. And now the last part of this question, if I erase all this off now, the question is also asking us to find out the conditional distribution of y. Let me correct myself. The question asks us to find the conditional distribution of x given y takes the value greater than or equal to 20. Let's just confirm this from the question paper. Also coming back to the question paper, conditional distribution of x when y takes the value greater than or equal to 20. So what are the values taken by x and the corresponding probabilities of x given that y takes the value greater than or equal to 20? Okay, so the values taken by x are 5, 6 and 7. What is the probability of x taking the value 5 when y takes the value greater than or equal to 20? So first of all, the favorable outcomes are how much? Probability of x taking the value 5. That means I am here in this particular row. Y taking the value greater than or equal to 20 means either 20 or 30. So 0.05 plus 0, which is 0.05 plus 0 divided by, what's the probability of y taking the value greater than or equal to 20? Probability of y taking the value greater than or equal to 20 means I add up all the yellow terms. This, and this. If I add all of them, it gives me the probability of y taking the value greater than or equal to 20. So 0.05 plus 0 plus 0.25 plus 0.05 plus 0.2 plus 0.15. If you add all of them, use your calculator, it comes out as 0.7. That means 0.7 is the probability of y taking the value greater than or equal to 20. That means I divide by the total number of the total, which is 0.7. So this gives me 0.05 over 0.7, which is, use your calculators and verify, it's 0.071429. Then what's the probability of x taking the value 6? 6 means given that y takes the value greater than or equal to 20. So probability of x taking the value 6 means I'm on this row, okay, second row, and y greater than or equal to 20 means I add this and this. These are my favorable probabilities, 0.25 plus 0.05. And again, I'm going to divide by the total, which is 0.7, which is the probability of y taking the value greater than or equal to 20. So again, this is going to be 0.3 over 0.7. And if I use my calculator, it comes out as 0.428, approximately 0.428. And then the last one, what's the probability of x taking the value 7? 7 means I am on this column. Let me correct myself. I am on the last row. I am on the last row when x takes the value 7. Favorable probabilities are 0.2 plus 0.15 because y greater than or equal to 20 means y equal to 20 and 30. So 0.2 plus 0.15. And again, I'm going to divide by the total, which is the probability of y greater than or equal to 20, which is 0.7. So this works out as 0.35 over 0.7. And if I again use my simple calculator, answer is 0.5. So this is my answer for the conditional probability distribution of x given that y takes the value greater than or equal to 20. Okay, now students who have subscribed to my complete lectures, complete course for statistics for business economics part 1, you will see that I have solved a lot of practice problems similar to this in my complete course. Okay, so you benefit the maximum when you enroll for my complete course for statistics for business economics part 1. So for all BBE honor students who are really want to perform well in your final exams, you will get the maximum benefits only when you enroll for the complete course on my Econ DSC app. Okay, so this is where I stop in this particular lecture. If I come back to the question paper, in the next lecture, I'm going to start with the discussion of question 2 parts. So I hope all students have enjoyed this particular lecture. Any doubts in this lecture, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this particular lecture.